All right, what's up? We're factoring polynomial equations today. So three things we can recognize when we can factor, factoring different kinds of polynomial equations, and recognizing and factoring the sum and difference of two perfect cubes. So just a couple of things. If you have a linear equation like this first example here, you're really only looking for the greatest common factor. So if I'm looking at 8x and 16, I can divide both by 8 or factor out of 8. And I'm left with x plus 2. The difference of two squares, we kind of talked about a shortcut to factor when you subtract two perfect squares last unit. So you take the square root of your first term, square root of x squared is x, square root of 9 is 3, and then, one positive, one negative in order for my b term to be 0. Any trinomial, any quadratic trinomials you can factor, taking a times c and then doing the box if you need. And that works for a general trinomial as well. But, so down here, example number 2, what we have is a trinomial, a quartic trinomial, though. The nice thing is we have 4, we have 2, so we can actually factor this using the AC method as well. So we'll go ahead and set that up. Because a is 1, actually we can use a shortcut. We'll still take a times c, we get negative 24. So we're looking for that factor pair of negative 24 that adds up to positive 5. If you're not sure, list them all out. You can go negative 1 and 24, flip the signs, and so forth. How about negative 3 and 8? Negative 3 plus 8 is 5. Negative 3 times 8 is negative 24. So again, if you want, like I said, you could use a shortcut. You can also use the box. Let's just use that instead. So my first term, x to the 4th, now goes in the first box. My last term, negative 24, goes in the last box. And then the two numbers we found, so negative 3x squared and 8x squared. So whatever goes in those two boxes is whatever's with your b term here, x squared. Before, like when we were factoring trinomials last unit, it was always an x, or I guess it could have been a y or any variable. But now if it's x squared, that's what you put in those other two boxes. So now you can go greatest common factor along the top row here, x to the 4th and negative 3x squared. I can take out an x squared. Along the bottom row, I can take out an 8. Left column here, I can take out an x squared again. And the right column looks like I can take out a negative 3. So, like I said, you can get x squared minus 3 and x squared plus 8, kind of like we did before, except this was a quartic instead of a quadratic. And then you should always see if you can factor further. Like if these were both linear, we would be done. But because they're quadratics, you should always look to make sure you can't factor further. So really, you would be looking for special cases like this one right here, which we don't have, so we're probably okay. All right, so special cases for the sum and difference of two perfect cubes. So I really wish there was a sweet song or something, a shortcut to help you learn or memorize this right here, but there really isn't. You're just going to kind of have to know it. So if you have a situation where you are subtracting two perfect cubes, which we do right here, here is what you need to do. So first of all, figure out what a and b is. A and b are the cube root of each of those. So let's start with the easy one. The cube root of 8 is 2. 2 times 2 times 2 is 8. The cube root of 64x to the cube, or x to the 3rd, well, I know it's x, but the cube root of 64, 4 times 4 times 4 is 64. So that would be a and b. Now, once you know a and b, you can fill in the rest of this. So a squared is going to be 16x squared. You got to square both the 4 and the x. Plus AB here is just A times B. So 4x times 2 would be 8x. And then B squared here, so 2 squared is 4. And that's it. And like I said, I wish there was an easier way to get it done. Oops. But no, that would be your answer right there. Again, you can try to factor this trinomial because it's a quadratic. You should always try, but you won't be able to. So here we go again. We are subtracting 2 perfect cubes, so we'll set this up. So first we got to take A minus B. Well, A comes from taking the cube root of the first term, so 2 times 2 times 2 is 8, so 2y minus 3 times 3 times 3 is 27. So there's your A and B to continue on with the rest of this here. A squared then will be 4y squared plus A times B, so 2y times 3 is 6y, plus B squared, 3 squared is 9. And again, you can try to factor that, won't be able to, that's it. So you're going to kind of just have to have this right here memorized when you subtract 2 perfect cubes. The nice thing is, when you add 2 perfect cubes, we can also factor. You can see that the shortcuts are very, very similar. So again, you're going to have this memorized. The only difference here is, so if you are subtracting perfect cubes, your first sign subtraction, the rest are addition. If you are adding perfect cubes, your first sign's addition, and then subtraction, and then addition again. So addition, subtraction, addition. Otherwise, it's the exact same thing. Just the first 2 signs flip orders. So here we go. We're adding 2 perfect cubes. So let's find A and B. So A will be 2x. B will be 3. So we're going to 2x plus 3. And then A squared would be 4x squared minus this time, because remember, from up here, we just flip-flop the first 2 signs. That's all. A times B will be 2x times 3, so 6x, and then plus 3 squared is 9. And again, try to factor. You're not going to be able to. All right, I'll leave this one last example here for you. It's very similar to one we just did off the left and up here, but again, your first 2 signs are just flip-flopped when you add. So, a few more you can try on your own if you'd like. Really just make sure you get at least one done. Try maybe a subtraction one here. Skip the rest if you need, and that is about it. The big thing is, again, just kind of having this in your back pocket memorized. It'll make your life a whole lot easier.